fill it in as we go through, submitted by the end of the class. And you should all get 100% if you're actually paying attention. Just saying. This is a freebie.
We have to do what to get 100%?
Pay attention. Or if you prefer to rent
Christina,
Hey, Shane,
if you prefer
did
to
you go to
always
Goldman?
rent attention.
I did.
Are they hiring?
Yeah, they are. They're hiring. They specifically want people from Alabama.
Really?
They got the lowest working IQ in the law. Alabamians.
Wow. Okay. So, make sure. Listening guide open. Propeller maintenance. And we shall begin. Torture number 4.
Why do you play torture?
I don't know.
I love it when you torture us.
Wow. Thanks, guys, for not immediately murdering her. I hope I see you on Monday, TV.
I'll retract that comment. I enjoy it when you torture me.
It's like toothpaste.
Not all
Once it's out, you can't put it back in.
Yes, I
Alright. So, we are going to be in chapter 7 of the textbook. We will talk about the parts of AVP-182 as we get to them. And then, we're not going to go specifically into this advisory circular, but that might be a really good reference during class time. On Monday, to remember that advisory circular goes in depth on maintenance practices for propellers, and it is in Moodle under resources. So, we'll have 2 sections of lecture today. The first one, you should understand propeller servicing, maintenance, and inspection requirements. And when it comes to major, minor repairs and alterations, what are we as AMP mechanics not allowed to do that we talked about yesterday? Generally speaking. Correct. No major repairs, no major alterations. So, we can do minor repairs and minor alterations only. And you can go to 43 Appendix A to look specifically at what those are. Other than that, the prop must go to a certified repair station or back to the manufacturer for major repairs, major alterations, and overhauls. So we talked through Appendix A yesterday. Let's see what you remember. If we have an aluminum prop, can we, let's say we get a little bend in the blade. Let's say we bumped the side of the hanger. We're just pulling the airplane out. We weren't even running the prop. Pulling the airplane out. Oops, not paying attention. Bumped the hanger door. Can we bend that aluminum propeller blade back? According to 43 Appendix A, FAA, are we allowed to bend the blade back? Correct. You can never, ever, on any kind of blade, bend it. No, cannot. What about a wooden propeller blade? Can we replace the tipping on that blade? No. No replace the tipping. Not allowed. Can we, so you had composite class. You learned how to repair composites. Can we repair a composite blade? No. Not allowed. Let's say we have a cute little airplane and we want to do some modifications inspection of our propellers, because we can inspect them all super in depth, forwards, backwards, upside down. Generally speaking, you do not have to remove the propeller for an inspection. Now, let's say you're not doing a routine inspection. You're doing an inspection for a certain type of pilot complaint. What bad things could the pilot be experiencing that would lead you to possibly remove the propeller? Oh, I heard it. Vibration. So vibration is a key thing. You may need to remove the prop and check it for what, maybe?
What?
I no. Why would you possibly need to remove it? To do what to it? Balance it. Check it for balance, which we're going to talk about. And it is, so first of all, just like your airframe, when you inspect a prop, don't clean it, give it an overall good look at, especially if it's a constant speed prop, to see if there's oil and grease leaking. Because if you give it a really good wash, and you wash away that grease, now there's no telltale sign of something going on. So first of all, look at it real close for grease checks, and see if any grease or anything's leaking out. And then do a good wash on it so you can look closer for nicks or cracks or anything like that. Come in. It depends on why you're taking the engine off. Yes, if you're sending the engine for overhaul, engine shop won't want the prop. Yes. Yep. Yep. Now there could be reasons like on the P26 where you do a hot section inspection, you split the engine, and you can leave the prop one. If you're just splitting the engine, you're taking the front half off. So you can leave the prop one and front half. So totally depends why. But yeah, if you're gonna send the engine in for overhaul, the prop comes off. This picture here. So big thing in props is safety. Is there anything in this picture that would make you go, I wouldn't do that? There's no chocks. I can't tell if there's a teeny tiny one there, the kind of reflection, but yeah. Even if it's a teeny tiny one, I would want a bigger one, especially if I'm on a ladder around the aircraft. So make sure you're chalked down, secured. Anything else?
There's stuff on the propeller.
Yeah, what's this Revive doing on there? Don't do that. Keep everything off the prop. Maybe he thinks it looks cute, but yeah, I don't know. Yeah.
Somebody doing underneath floating engine oil lipstick on the prop, so the pilot can see it.
Wow. manufacturers will have different criteria for retorquing their bolts. So this is kind of a generalization right after the first flight, and then again 25 hours after that, and then again possibly 50 hours, and then that's a back it off and then retorque it to make sure it's snug down. Clean a wood prop, warm water, mild soap before you do your in-depth detail inspection. Ooh, yes. So, did anybody ever want to see a video of prop coming off?
Yeah.
This is your chance. Here you go. And this is a really good reason why you must follow proper technique.
Have you ever noticed the farther you get from home, the closer you get to where you belong? The Mazda CX-50
Here's one. So if you see that starting to separate, that is common, unfortunately, but very bad defect. Dents or bruises in the surface. So bruising would be unique to wood. We get dents and cracks in aluminum, but wood can bruise. Cracks or scars across the back or the face. Broken sections, that would be pretty obvious. Warping. Warping is unique to wood. So if I sight down this propeller and it's going, we know my wood is drying out or getting moisture in it unevenly. And then worn or oversized bolt holes or the bore of the wooden product. The prop here is a wooden prop with composite overlay, and that guy had a story. He heard a bang on takeoff with significant vibration. He returned to land safely. On close inspection, you can clearly see water ingress in the wood core. So you see all this water seepage into there. I have inspected the prop many times and never noticed any cracks or chips to be concerned with. The prop has not come anywhere near water in the time I've owned it, which was about a year. But the old hanger was a bit damp, being a fabric tunnel with a mesh door. I suspect it's been wet for a long time and then finally decided to explosively delaminate. The wood inside seems surprisingly soft, and he says being carbon fiber finish, I'm guessing it would have been harder to spot a crack or an imperfection than it would have been on a painted surface, which I would think is true. He figured it was a manufacturing defect, possibly. So everybody get 3 common defects in the wooden prop. Anyone not get it? Okay. Some more common defects, and in case you didn't get one of those. Loose or slipping metal tipping. I'm gonna grab this guy. So, as you see, this stuff starting to come loose, or you see that it's slipped out of position, that would be of concern. And any loose screws or rivets. So you have to check every little screw or rivet in that tipping, make sure it's not loose. And looking at cracks in the solder joints of the metal tipping. So a new joint and solder, make sure there's no cracks in there. And here's a nice big scary crack through it. Questions on defects? So here are things that you can do to wooden propellers. So small cracks parallel to the grain or small cuts may be filled with resin, glue, and resanded. How would you know how small is? Owner's operator's manual. Or you may have to go to a field maintenance manual possibly, but yeah, one of those. Can we completely replace the entire fabric if it has fabric cover on the tip? No. Correct. But if less than 3/4 of an inch, little damage, we can repair a small, tiny defect. You can resolder a joint on metal tipping. We cannot replace this tipping, but if there's needs a little bit of resolder, we may do that. And should also pass to that exact same place. If it's not, if I'm like, and they're passing through two different points, if it's small enough, you might be able to place shims in inner flange of the hub to correct a little out of track. Again, that would be for just a little out of track. There's limits to how much you can change that. Things that cannot be repaired would be cracks across the grain. So if we have a crack coming down like that, can't repair that. Prop gets rejected. Split blade, that's pretty obvious. If it's split apart, you gotta reject that prop. Cracks or damage to tipping on variable pitch blades. So a wooden variable pitch prop, extremely rare. But if it is, that blade has to be rejected because when it can change a blade angle, it goes through so many more stresses that you cannot allow damage on the tipping. And then oversized or elongated bolt holes. So if that bolt has worn itself out and worn out the wood, this is actually from a sailboat, not a prop, but it's an elongated bolt hole. You must reject the prop. And I mentioned the other day that you need to store a wooden propeller in a horizontal position, like that. Why is that? For even seepage of any moisture, so one blade doesn't get heavier. Horizontal and cool, dark, dry. That sounds so depressing, but well ventilated area. So cool, dark, dry, well ventilated. So I believe in your listening guide you have to list 2 reasons why you would reject a wooden prop. So cracks across the grain, or split blade, or damage to tipping on variable pitch, or oversized bolt holes. So any 2 of those go into that one. Anybody not fill that up?
Did you say exactly how far out of track that is?
We'll talk about that. Or later today, talk all about that.
I know you mentioned it.
Excellent question. Excellent. Now, onto aluminum props. Any questions on wood props before we leave those? Okay. So aluminum props, to inspect them, and this is also on your listening guide, 3 inspection items on an aluminum prop. So first of all, we're gonna, first of all, I'm gonna just look at it, see if there's any obvious damage, any oil or grease leaks, and then wash it with warm water and mild soap. If your prop is regularly exposed to salt water, you should regularly rinse it with fresh water so it doesn't start to build up corrosion. And then annual and 100-hour requires inspection for cracks, for nicks, for proper torque and safety. So you can write cracks, nicks, proper torque and safety. If you suspect a crack and you have proper training and resources, or you can send it out, you need to dive pen it to double check that. That'll show you if it's just a crack or a scratch, but then you must wash off that with a solvent to counter the effects of that penetrant. Also, you need to inspect the hub for damage and corrosion, and each of the bolt holes for cracks, excessive wear, and proper dimensions. Can you see the cracks on this guy? Right there. So now, so you have to look for it, and especially on a real prop. You gotta really look close. Everybody got three things to inspect? Yeah.
Some of these metal props, like certain other things you can like paint on them, and if they have a crack, or they'll be like a dull.
Oh, like a compressor blade?
They have vibration. Yeah.
Not really. Not, yeah. The cracks are start out so minute that they wouldn't really affect. It's a very good thought. I feel like you should try it. You should experiment with all the blades that you have out. Any other questions? Yeah.
And you mentioned our inspection check for proper reports and safety rules, but when did you have to check the safety check before, or do they just ask you, like, how do you check for the safety?
Check. So hopefully they're using torque strike paint. But if not, then you gotta go to safety, make sure the torque's greasy. Any other questions?
Can we use an open-ended direction and the torque wrench just to get around the safety loader? Do we still have to cut the safety loader?
Not on my prop. Try it, go ahead. Try that on your practical. Make sure you have whatever costs to retake. Ooh, alright. So, I'm gonna show you. I just flashed it up there, but I'm gonna show you a picture again. I don't want anybody to say anything, just quietly look at it and decide to yourself if anything is wrong with the safetying of the prop we're going to show you. If you see something wrong, raise your hand, or there might not be anything wrong. I might try and trick you. What? Shush! Shush! Everybody be quiet. It's so nice. They're tight. Look at those twists. We got really good twists in there. It looks nice tails. Nice tucked in. What do you see? I didn't say what you said.
Reverse thread.
Whoa! They're not. Alright, somebody. Yep.
The safety wire was some acid.
Ruh-roh. We are bringing this in a loosening direction. So this was, he had a whole article on installing this prop, and I was reading through, and I was like, he didn't fly like that, did he? And then later down in the article it says, by the way, for those of you that freaked out, I did recognize that before I flew, and I resafetied it. Whew, okay.
I would have
I know! I'm taking a new picture.
Yeah. Yeah, but the FAA is coming.
Yes. That's probably why he put the disclaimer. He's like, oh, I did it right, I did it right. Okay. So, back to aluminum props. Any nicks in a blade, like we got little one right there, must be repaired as soon as possible to eliminate stress concentration points and prevent fatigue failure. So you remember that video that I showed of the narrator talking about vibration. That's painful. And where you saw like the one mode and the two modes. So imagine if that prop right there, that's gonna propagate into a crack.
Propagate.
Thank you. Very quickly. And that blade is gonna go off, go bye-bye. Set up violent vibrations, so then your engine might go bye-bye. So, defects on the leading edge, the trailing edge, the back, and the face may be dressed out using files. And then polished off with fine sandpaper. So you all are going to get an opportunity to do this. But the tricky part with the prop is, especially on the face of the blade where it's super flat, if I tried to use, now obviously, I'm using this because it's easy to carry around. I can't do this on a wooden prop. I'd be having an aluminum blade. But if I try to use a flat file on there, I'm going to damage a massive amount. I want just something little and tiny and round that I can just work out the actual little nick itself. So, that is why they say that you need to use a riffle file. It looks, might be a little hard to tell, but it's curved this way and that way. See how almost like the back of a spoon surface, to just focus that filing on the nick itself and not remove more material than necessary. And I do believe that will be a couple question. Does the riffle file should be used on the face of the blade? And it's also useful for the rest of the blade too. So you can really concentrate where you're going to file. Very, very important that you make repairs parallel to the length of the blade. I can actually use this portion of blade, which something bad happened to it. But whenever you get a nick in the blade, you must always be filing parallel to the length. Never ever be filing like this, or you will fail and you will be given a brand new nick and your prop for the left. And that could fail you on a practical if they catch you doing it. Why would that be?
Causes stress points
dirt. You're not making actual nicks to start a crack. It's just eroding away. No sharp points that are going to turn bad right away. And it looks a little rough. I mean, the paint's worn off here, so it looks not lovely, but it doesn't hurt the prop. Doesn't damage it. It's not gonna change aerodynamics. Some people like to have a really pretty prop blade. So they will take like the shaft of a screwdriver or a smooth dowel pin or something, and they'll come to their blade and they'll just roll it and kind of burnish it and smooth all that metal back down into itself, kind of squishing it back down into itself. So when you run your hand, it's nice, perfectly smooth. What are your thoughts on that? Before I tell you my thoughts on that. You might already be figuring out my thoughts on that. Thomas.
Well, obviously you'd hide any like minute evidence of cracks.
Gold star. Any other thoughts? I kind of told you my thoughts, but it's okay. You disagree.
The pilot wants it, the pilot pays for it.
Ooh, pilot wants it, pilot pays.
As long as they're paying me by the hour, I'll do it all day long.
Until this prop is just a little narrow. Other thoughts, or those of you that are pilots, have you seen your mechanic do anything like that to your It's okay. Just small judgments. Yeah.
It's one of those things that are like, it doesn't affect anything, so why would I waste my time doing it on personal aircraft?
So there's a thought. If it doesn't affect anything, why waste your time to make it look visually appealing? What it do on his aircraft? So Thomas hit on the biggest thing. There is potential that as you roll that blade and smush that aluminum back where it came from, that you are covering up something that could potentially develop into a crack. So there are people that you might run into that I highly respect that do this on a regular basis. So if you hear that, that's their choice. Thank you. But I would highly recommend don't do that on your practical. We're going to look at some manual excerpts. I talked to Dean about it, who's been around, not actually 100 years, but he's been around. He's done maintenance. He knows so many people that have done maintenance in different ways from different teachers. He's gone to, I forget how many, he said, prop seminars from like Lehigh and Hartzell, like propeller manufacturers, and he said they never, ever, ever even mentioned burnishing. So he's like, don't do it. So if Dean says don't do it, then don't do it. Yeah, well look, I'll talk more on that when we get to the manual expert. But now you know my opinion. If you're just making it look pretty, there's better options that we are going to see. So this is an excerpt from AC 4313, and it begins to tell you how some of the ways you would go about. So here we have a nick joint, and we want to remove all those sharp edges so we get rid of any possible stress. So we want it very nice and round and smooth. So, and I'm going to show you later, the smaller and more round the file, the better. I love this little guy. Unless you have a really big nick, but then it might be too big, it might have to go to the repair station. But just little files. And you need to get that'll give you the nice gradual return to good airworthy aerodynamic quality. Here's another one. Remove all the sharp edges, make it nice and round. On the face, what kind of file would you need to use on the face? Riffle file, yep, to get it nice and round. So if this is a crack, or not a crack, because that you probably can't repair, a nick, a little dent, round it out to get rid of all those rough edges. So then we're going to look at some Hartzell and some Macaulay examples and see the differences. But Hartzell says anything greater than 0.31 needs to be removed. So when you run your hand along the prop, you're going to feel the erosion. And it's going to feel kind of bumpy. But if you take your fingernail along it and it catches, it's probably deep enough that it would need to be repaired before flight. But if you're not sure, you can actually measure it. If it's more than 0.31 on a Hartzell, then you do need to file that out before you fly the aircraft. And it says files electrical or air-powered equipment. Be really, really, really careful. I highly recommend just do it by hand. A lot better feel, a lot better control. Keep it much smaller. And then emery cloth, Scotch-Brite, crocus cloth. Now look at this. Rework that involves cold working the metal. What would burnishing fall under? Cold working. Resulting in concealment of a damaged area is not acceptable. A stress concentration may exist, which can result in blade failure. So now this is under the section that talks about actual nicks and scratches. So obviously you cannot burnish out a nick, which the people that do burnishing, they would not do that. They would file out an actual nick properly. They're just burnishing erosion. So they're not doing this. But this beats me, I'm like, does that make burnishing erosion a gray area? And I don't want to go there. So I wouldn't even personally try to do that. Yeah, so that's, if it talks at all about cold working, the manual is strongly advising against it. And then, repairs leading to trailing edges, remove material from the bottom of the damaged area. So in your nick, you're going to take it out at the bottom so you get that nick totally out, and then work it out to the edges. And you take the depth of the nick times 10, and that is how wide you have to make your repair, then file and sand. And then inspect the repaired area with a 10 times magnifying glass to make sure there's no indication of damage or file marks. So kind of like when you sanded out damage on plexiglass from your first sandpaper, then you had to remove all the marks from that one, remove all the marks from the previous one. Same thing with this. Remove all the file marks with sandpaper, remove those sandpaper marks with crocus cloth so it's perfectly shiny and smooth. And here they're just showing you if you have this much damage, you need to widen it out 10 times. There's another example. We're going to look later at more of you must keep the profile of the blade. And the last one on the Hartzell. If inspections show any remaining blade damage, then you gotta go back and start over again. And then don't forget corrosion. Treat it for corrosion
smooth with it. Yeah, he's very smooth with it.
Yeah.
Precisely.
So,
Just
so
reverses gravity for a second, so we go. Ta-da!
What are you doing this morning?
Abracadabra.
Over the dungeon?
Jump from like the highest.
Ignore them and continue on my way.
And you're fine? Yeah.
and I'm busy right now, so.
Oh,
Do I just scan it? Very good.
Oh no.
It's his birthday tomorrow.
Oh, right. Very funny.
How out of balance will a great big frog stuck in one side of the propeller hub, halfway hanging out, cause for about a Cessna 150?
I think I should ask you. Sounds very specific.
It was fresh too, whoever flew before me.
How did a frog get in there? What did a
So I had to take my left foot,
Ew.
and it's attached, and then all its intestines are detached, and it still has blood and I mean, it was not mummified, it was not blood congealed, it was a horrible experience. And then I looked in the fuel tank with a flashlight, another frog.
What?
They must have cared a
In
little
the
bit.
fuel tank.
What's going on?
Oh, we're reviewing frog stories. And see,
How did it get in that fuel tank?
He's like,
I don't know.
how would you fix
I've
it?
seen
Just have like a single
delivery.
So I went over to the mechanics.
There's some questions
Frog
he's
is
asking about it.
There he goes.
Or I guess 1600.
Here's one fire, switch it out.
Oh.
We're okay.
He's like, what did you just say?
Oh, got it. And he was only a penny about that.
Yeah, that's what he used to matter.
Not like someone could bring in the propeller, but I was just wondering, how much else difference would that for you? Something significant.
Oh.
And it just is right there.
Yeah, we were just
For the next mile, mutilated frog. Right by the line.
Gather in, gather round. Into the not sunny classroom.
You know what you need? Sweat needs to get one of those picture light
Oh, you should like skylight.
Oh, not like a skylight, but it's like that.
Talk to Barbara. She said that that's salty back on this person.
The dentist that we go to.
If you can hear me clap once, you can hear me clap twice, you can hear me point to all the people that aren't paying attention. Oh no! Alright, we're gonna keep moving along, so hopefully we'll have some more time at the end. So, we talked about Hartzell, which is a major propeller manufacturer. And now we're gonna talk about Macaulay, which is another major manufacturer. I like Hartzell better than Macaulay because Macaulay said you can't have our manuals anymore unless you pay many, many, many money. But anyway, not Colby. must be for controllable pitch at least 6 inches from the hub socket. So why do you think they are saying that you are not allowed to repair damage in this area? What's critical about this? Yes, this has given us the strength. So if there's damage now or strength is compromised, you gotta send that to a certified repair station to be repaired. You're not allowed to do it. And here is the one I wanted to talk about from Macaulay. So Hartzell says no cold working. Bless you. Macaulay says, Macaulay does specifically talk about that erosion damage. If the propeller blade has erosion damage and there are no signs of corrosion, no further action is required. However, it is recommended that erosion damage be protected from corrosion with a chemical conversion film coat like iodine and touch up the propeller paint in accordance with blade painting procedures. So they're saying when you have erosion, just periodically touch that up with some iodine and then keep it painted to help prevent that from corroding. So that is what they recommend. Doesn't say anything about erosion. Yeah.
Wouldn't it just erode even further and then just
So some of those wood could eventually start to develop into little nicks and cracks, and then you would just file it. Which Dean said sometimes when the erosion got really bad, they would just take like 300 or 800 grit sandpaper, just go over it, get that erosion out, and then sandpaper it with finer, finer, finer until it was smooth, paint it up. But yeah, there are times like, okay, I'm gonna just smooth this out. Or yeah, with my leading and trailing edge repair procedures. So we'll kind of step through this as a guide for you to follow when you get your lab assigned, which will hopefully be later today or for sure on Monday. So the first thing you're going to do is determine the depth of the damaged area. Because if it's too deep and it exceeds limitations, then you can't even repair it. You have to send it to a certified repair station. So you measure it. Ooh, everybody remember how to use one of these little guys? Yes. If you don't, you can refresh yourself or grab Ryan or classmate or yeah. Anyway, so you get a little depth gauge, measure the depth, so you set this over it and this little needle goes down in the crack or the nick. And then, so Macaulay says damage that's located in leading or trailing edges must not exceed 94 thousandths, which is very little. And then remove metal at the damaged area, starting back from and working towards the edge. So when you have a joint, a nick in the prop, you're going to start right in the center of the nick, away from the edge, and just work out towards the edge to work that nick. Whew, look at that movement. Whoa. So file strokes must run from blade shank to blade tip. You are always filing shank to tip, always with a length. Never ever like this. Or I'll recommend you to Taco Bell. Change it up from McDonald's. The length of the blended area shall be equal to 10 times the depth of the damage. So when you measure that damage depth, then as you blend it out, that needs to be 10 times the depth. So you're sure you're doing all the damage. Then it says refer to figure 802. What is figure 802? Oh, there it is. So our little damage, comp, stone bit out part of the prop, they measure it and figure out what 10 times it is. Or some manuals will say 5 times on either side. So if we have 5 over here, 5 over here, that equals 10. kind of lose track of, whoa, where's my 10 times? So marking it with tape is really, really helpful. You can also, with the tape, mark the center of your nick, and then do your 10 times or 5 on either side, and mark that. So that kind of keeps you in that 10 times. Now, 10 times is a minimum. You must do at least that. You can go a little beyond that. You probably will accidentally do that with your file anyway, to make it smooth. So you can go a little, but what are you doing? What would be a downside of going too far out? You're removing material. So you have to remove as much material as it requires, but as you're making it smooth, you are removing more material, so you're starting to shorten the life of that blade. Because now if we get another nick in there and we remove more material, another nick, more material, eventually your blade will look like that. Now we can't fly. So remove enough to get it nice, your airfoil shaped bag, but don't go crazy. Rein it in. Yeah.
You have to like repaint it or put something.
Correct. And we'll talk about that. But yeah. So mark locations helps you keep track of where the center of the nick was. Back to Macaulay. So the finished repair should be the depth of the original damage, so whatever that was, plus 0.031 inch. So why do you think they want you to go a little bit deeper than the actual depth of the original nick? Yeah. Exactly. You don't know how deep, like there could be little hairline cracks that you cannot see with your eyes that are deeper than that. In this, they, with tons of testing and stuff, figured out this will take care of that. In an initial removal, material should be done using a small, smooth cut mill file. All traces of file marks in the repaired area should be removed with number 240 emery cloth or equivalent grit sandpaper. So Macaulay gets super specific. And this says should be removed with, so if you have something close to that that does the job, that's alright. So back to this, going a little deeper than the actual nick, because your eyes are going to see that here, but look at these lines of stress are affected the whole way down to there. So going beyond will get rid of all those stress risers, rounding it out through all of that. Any questions on that so far? Then, like I mentioned, using a half round or round file. That's a pretty big file. But the more you do it, the more skilled you get. You can use something like that. But half round or round works best. Make sure you file down to all traces of the nick are removed first. So you focus on just the nick area. And then, once you're sure you have that completely removed, then you taper it out to that 10:1 specification. Or 5 times the depth on either side. And file it out till no trace left. And then you'll reprofile, work it out with sandpaper until you blend it completely smooth. So no sandpaper and mark, you're finishing off with crocus cloth or emery cloth, making sure it's completely smooth. Yeah.
Is it also important when we're sanding to go in that one wrong direction?
It is. Thank you for asking that. Yes. So filing and sanding all must be with the length of the prop. So I've been emphasizing that exactly, that you must go with the length of the prop. And making sure you get that nick completely out. And and then do the 10 to 1. But there is something else. What do you think? This is gonna hurt me a little bit, but. So if I'm aggressively filing like that, I'm showing you this cutaway on purpose. What is starting to happen? Oh, I'm gonna be really bad and use the flat side. Oh, that just hurts. I can't do it. So, what if I'm aggressively filing this? What is gonna start happening?
Greasing your blade.
Okay, oh, this hurts. So I'm just, yes. What did I say?
Are you rounding over the corner?
Correct. So this is leading edge. I am flattening out that leading edge. So now, this is not gonna be a proper airfoil shape. Instead of coming up and nice and being real good leading edge, it's gonna go up and flat down on the back. So as you're filing, after you work out the neck, because that'll be like small, fine work. When you go to a bigger file, when you're filing, you're gonna, and I'm doing big motions so that you can see you're gonna be working much smaller, but you'll do a file this way, angle, 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 come over, angle, angle, constantly maintaining that leading or trailing edge profile. So when you look at it, it should have the exact same profile as when you started. So keeping that leading edge profile super important. And here are some pictures of that. So here we had to remove some material, but we kept this shape the same, even though it had to come down a little bit. It's the same as that shape there. Here we just turned it into a little pug dog. Squish his little nose in. So, and then same thing over here. This got super rounded off, where this one maintained that leading edge shape. Any questions on that? I'm going to show you a picture, and you tell me what you think of the filing job that was done. So the nick was right in there, and they filed it out. What are your thoughts? Would you say that's good, or would you say you would work it out a little bit better, or you could extend it, fly it?
Looks like it needs more working.
So you got some more working.
If that dark spot constitutes it.
Perfect.
I looked at that more next too.
So if I extend it,
No, it's difficult to tell from this angle.
Doesn't seem like.
I can't come down with a judgment yet.
so we got maybe not 10 times. Other thoughts? What's it?
Wow, the biggest area.
Maybe file too much.
It looks like there's another neck.
Looks like there's another like down there.
It's like using electric to just so clean.
Ooh. So we have too much material, we have not enough material. I like this discussion. We have not enough information to set a judgment upon it. Other thoughts? So here's my opinion, my humble opinion that may be debated. So this is a teeny tiny area. So it looks, and it's hard to tell, so I actually saw this in person. So it was pretty shallow. So I think they did that 10 times. But it is down in the leading edge. So if I were to slice this prop and rotate that removed the stress risers, they removed the nick, they did the 10-to-1, but they did not re-profile that leading edge. So they should have come down and just smoothed this out, smoothed it all. Now, it would have removed more material, which is probably why they didn't do that, but I'd rather have a recontoured, good leading edge, so my prop is performing properly, aerodynamically, along its whole leading edge, and this would more quickly set up another stress riser right on these guys than if you had correctly filed that out. So you'll see things like this. There is a compromise between only removing an absolute required minimum of material and getting a absolutely perfect profile. So I've had some students in the past, the blade looks beautiful when they're done. Like you can't even tell there was a nick in there, but they would file, like I'd give them a nick maybe in here, and they ended up filing like from there to there. And now you look down it and you can't see any indentation at all. And they reprofile the leading edge perfectly, but the entire leading edge has been brought back a couple of millimeters. So you really have lost prop cord, which is something that you'll need to measure because there are limits to how small of a cord you can get. And now maybe you had to discard that blade because you filed too much, which would be a bad day. Yeah.
How significant? This is not significant for us, so we have to weigh it and balance.
You might. And we'll talk about that. But yes. So if you have a significant nick, you may need, and if you find there's vibrations, you may need to balance it by removing material from the other blade, or there's some other options as well. So then it says smooth the repaired area by polishing with number 320 emery cloth, 600 grit emery cloth, or equivalent grit sandpaper. AC 4313 says crocus cloth. It is very, very important. Do not use sandpaper or emery cloth that contains iron oxide on aluminum propellers. For now, we've introduced corrosion. So be careful what kind of sandpaper you order. It does not contain iron oxide. And here we go. Final result should be a repair that is shiny, smooth, there's absolutely no stress risers. Go from coarse up to 600, then 1200 in steps to the final finish with no scratches left. So it looks like our nick was maybe in there because we see a little bit of kind of color change, but you shouldn't be able to tell exactly where the nick was at the end. Then, here's what Macaulay says, determine the depth of the repaired damaged area. So if you're taking the whole front of the, or leading edge of the blade and filing that whole thing down and you have no tiny divot left, there's no way you can actually determine the depth. But they ask you to do that. And the depth of the repaired area measured and can't exceed 0.125, where now you're done. Probably have to go back to overhaul that blade. Here is a cool thing that Hannah and Caitlin discovered, I forget, last year or the year before. First time customer came to the LLC and said, hey, I forget what work they were actually doing. If it was something on the prop or if they just happened to find, I think it was something on the prop. And they were going to maybe repair some nicks on the blade, but being as fantastic, amazing mechanics that they are, they're like, we're going to go to the manual, boom. And they found this diagram of how, so I talked about there's limits to how much material arrow you can remove, because if your cord gets too small, then your blade is done for. So like, this blade looks suspiciously small. So they laid it on this diagram that has minimums. The minimum for this blade is right there. The new blade would have been up here. So we're like, sorry, customer, but you need a new blade. But it's so good that they thought this, they did this, so then they didn't waste time blending out nicks that would have already been beyond limit. So it's also scary to know, apparently there was some shop out there that was filing this down below limits and either didn't care, didn't know, who knows what. Thankfully he came, we could have shut. And now can fly safely with a new prop. So watch out for stuff like this. Never assume that you're receiving anything in good condition. Then, after you filed it out, sanded it out, blended it beautifully, finished it up, shiny smooth, then you'll need to etch and iodine it or whatever your manufacturer recommends. Really, really important if you're not doing if you're doing the whole prop, you just take it off the plane to make it easier. If you're doing it on the plane, especially it comes to speed prop that has all kinds of special oil and seals and mechanisms up in the hub. Make sure you turn the blade down so all of your solution runs down the blade and not into the hub, or then you will be getting a new prop. So etch, iodine, make sure you collect your chemicals, and then after that process is done, you'll paint it. I mentioned this the other day. How are the blades of a constant speed prop, how are they labeled with model and serial number? What is it? There's a sticker on the blade, and it will also be stamped down on the root. But how often are you going to see the root? Probably never. So make sure when you remove that sticker for painting that you just write that information on the hub so it doesn't get lost. So make sure you transfer that information before you paint it, or you'll be in a sad way. And then when you're painting it, the face of the prop that faces the pilot must be painted a flat black. Why do you think that is? Why can't we paint it purple with pink flamingos? Anything pink. Exactly. If it's anything other than flat black, it's going to reflect, and it's going to look like a spinning hypnotic disc for the pilot. We don't want to hypnotize pilots. So it must be flat black. Yes.
Why the tips generally?
You took the words from my mouth. So, you must paint the tips an alternating, very visible, some kind of striping. I'm going to throw it back to you. Why should that be? I think David was first. So you can see it. So when you're walking up to a prop that's running and spinning, this visually creates an arc. You do, maybe not a hypnotic disc, but you want a visible disc for people out working on the ramp. They can look and they go, whoa, that's a blade spinning. I better, now hopefully they can get the engine running. But a visible blade spinning you also need. So you need to replace the white visible stripes. Super cool thing that MAF does, and you can see this on our 206, it's on loan from MAF. So look at these comparisons. So the arrow strap, 2 stripes. And the F206, 2 stripes, 3 stripes, 4 stripes. That just makes it a lot more contrast, a lot more visibility. So if you ever hear them running the 206, you can go out to a very safe, distant position and look at the front of the prop, and you can see it's super visible. You see this whole big spinning arc when it is running. And they do that for all of their aircraft to make them more visible because they're, especially overseas, flying where children are, people don't necessarily understand, but they see that like, whoa, what's that? So to make it hopefully more safe. I think you're okay.
The strips, are they just expensive? Or should they
Correct. And on the forward, just the back portion of the propeller, the portion towards people, the entire face of the prop must be flat, or else the pilot can be. Hey,
Why would you not just paint all of it 4 stripes?
They researched it and they figured out this makes it more of a, let's say I wrote down the word, strobe effect. So having alternating stripes actually makes like a strobe effect.
Zebras.
So I was like, whoa, whoa, whoa.
Is that not making a difference on balance of having like?
It's the same amount of paint. Well, because you would mark this off, paint this way, paint. Yeah, it doesn't affect the balance. Right. Yeah. Paint can affect the balance. That's a very good thought. But doing it correctly, it doesn't. Yeah.
So we can drop it.
Sure. Any other questions so far? So then, moving on from the blades, still to our aluminum props, the shanks. What portion is the shank?
Down by the root right there.
Yep, down by the root, before the actual blade, kind of round portion, giving us the strength. That is unrepairable. We already talked about it because try to repair that, you may be compromising the strength. Any size transverse crack is unrepairable. So just like the wooden prop, same thing for aluminum. If you have an actual crack running, it's more than just a nick, it's a crack. Goes to the prop shop. Hub area, all you can do is remove light corrosion. So if there's any crack in the hub, we can't do anything with that. Only remove light corrosion. Where's the crack? Where's the crack? Why can't I see it? Oh, there. It was a nick, but now it's propagating into a crack. So when you do have a nick in a prop, really look close. Good idea, maybe magnifying glass to make sure there's not a crack starting from it. Not a creak either. Also, if one blade is shortened, all other blades must be shortened the same amount. But can we do that? Nope, that's a major repair. But they'll ask you that, like, if one blade is shortened, what happens to the others? Obviously, there's limits. You're not just gonna chop that off and say, send it. A bent blade may be cold straightened by a repair station or propeller manufacturer. So if these things happen, it might not mean that your prop is a total goner. You may be able to send it to a repair station, but sometimes the cost of repair versus the cost of the new prop is, which is better? that station number, because depending what station it's at, your manual will say it can have this much bend or that much bend. So you had to measure out from, where's 0 station? The center of the hub, measure out, mark your station number. You may need to measure thickness of the blade, the chord of the blade. Might be things I'll ask you to measure. And then you would need a special protractor tool where the hinge goes over the center point of the bend. You measure the angle of that bend, and it would tell you on your protractor tool. And then there would be a chart. Now, I just have the Jeppesen because most of these would be like an overhaul manual. You wouldn't necessarily even have access to it. You have to just send your blade in and not check it first. But it'll be a chart, something like this, where it would have the blade station number. So at station 22, we have a 10-degree bend. Anything below this arc is repairable. So we're back, okay, we can send that to the prop shop, they can bend it back, we're good to go. But if we have at station 22, a 15-degree bend, is that going to be repairable? Nope, it's outside of the arc. So anything out here, bring the blade to snap for demonstration. Get a new prop. So that's just so you're aware of that. That would be, you might maybe do that to see if it's worth sending for a repair station, but it's pretty much just the repair station would work with that.
Christina,
Yeah.
many months ago, Brian said something about when you have a prop strike and your engine is running.
Yes.
Are we going to cover these things forward or versus backward?
We can talk about it right now.
Okay. I was just curious.
Yes.
Just a rule of thumb.
Yes. So, what forces are happening when my propeller is spinning? What force, sorry guys, you, what force is supposedly trying to take this blade out?
Oh, is that
Centrifugal
centrifugal
force.
force?
What force is, as this blade is spinning this way, what force is trying to blink it back the other way? Torque bending force. What force is, because of pressure, center pressure, trying to twist this to a higher blade angle? Ooh, aerodynamic twisting force. What force is trying to pull this into the plane of rotation path of least resistance? Centrifugal, I think technically it is inertia, but tell. Centrifugal twisting force. Centrifugal twisting force is trying to make the path of least resistance. And then, what force is trying to bend these blades forward at the tips? Thrust bending force. Because of thrust, or maybe resulting in thrust, what kind of pressure do we have ahead of the prop? Low pressure. And what kind of pressure do we have behind the prop? High pressure. So that's trying to make those blades go whoo. So if we are at high RPMs and we have something that suddenly stops our prop, where are those blades going to tend to go? Whoo, forward. Whereas if we're at a low RPM or we taxi slowly, taxiing along and hit a snowbank, then that may force them back. So, did that answer?
Yeah.
That sounded.
Yeah, no, that's super helpful. I'd like to propose what we call it centrifugal force.
I love that. But I don't think I can say centrifugal.
I'd say
centrifugal force.
Any other questions on aluminum blade propeller inspection repair? Okay. We talked about ground adjustable propellers. Inspect the blades just like any other prop, but these are really important to pay attention to the blade retention shoulder area because they are ground adjustable. You want to make sure your mechanic or you actually adjusted them, torqued everything correctly, and you're not getting stress cracks in the shoulder retention hub area. And that pen is highly recommended for inspecting the hub because you could get something like cracks starting where that blade is forcing against the hub internally. It can start to get cracks to form. So really look closely at both, and that could be a test question. Blade retention area of the hub of a ground adjustable prop. Any kind of prop, but they like to emphasize ground adjustable. Constant speed propellers. So now, if you remember back to that, I think it was a Hartzell video I showed, that they have 120 parts all in that hub of things working together, mechanisms and seals and greases in there to change the angle on the blades. So, in your listening guide, it asks you to list 2 items to look for specifically on a constant speed prop. So I want things specific to constant speed that you would not have to worry about in a fixed pitch prop. So that would be looking for oil and grease leaks. Also, looking for loose blades or excessive blade rotation. So oil and grease leaks. And then the second one, loose blades or excessive blade rotation. Because they're in there, they are anchored in there, but it is mechanical, it's bolts, stuff, clamping, holding them on. So if any of that fails, it could get loose, wiggle, wobble. I mean,
Why loose blades is specific to constant speed? 'Cause some fixed aren't there. It's still like 2 blades to fix it.
very good question. So a fixed pitch prop, when they're talking about a fixed pitch prop, it is always one prop made out of one solid piece of aluminum.
So our little wooden prop guy, what's that? Like
It's not a real prop.
it's not like real.
That could be an exception, but its blades come out, so the pitch can't change. That's a really good question. Pitch can't change, but you'd still check it for wiggle wobble. I am not aware of any certified props that would be like this. A fixed pitch would be solid wood, solid aluminum, one machined out of one piece. And then constant speed, obviously the blades can be moved.
So like, sorry, like there's the ground adjustable, so that's not fixed pitch because you can just adjust it.
Correct. Correct. Yes. Only on the ground, not in air, but it still can be changed
Okay, thank you.
by a mechanic. So, with a constant speed prop, some get lubricated, some do not. We're going to talk more about that. But you must lubricate them according to manufacturer's guidelines. And then repair in accordance with aluminum prop guidelines whenever applicable. For a constant speed prop, all overhauls, major repairs, major alterations must happen at a certified repair station or back to the manufacturer. So with the blade wiggle wobble, it's actually a very specific wiggle wobble. So this is an excerpt from Pretzel, of course, because I like that. So they give you a really good diagram of in and out play, radial play, end play, leading edge and trailing edge play, and they tell you for each one of those exactly how much is allowed. So you would have to carefully measure each one of those. And what that looks like is, so in and out play, grab it and you yoink it out, shove it in and see how much that moves. So I'm pulling out, pushing in. And then radial play, so you grab leading edge, leading edge, trailing edge, and you're moving it like that. So I'm pushing that way with this hand, this way with that hand, and then that way, and you see how much wiggle wobble it is. And then end play, so you go forward, backward, and then leading edge to trailing edge, go up, down, up, and you have to support this somehow to see how much that wiggle wobbles. Also, while I'm here, I remembered one way back to wooden props, to check if your laminations are starting to separate. You make sure it's, if it's fixed pitch, it'll be easy to do. Make sure you're secure down here. Grab the tip and just twist it. And if the laminations are trying to separate, you'll see that by twisting it, you'll see it when we go eek. So that's a good way to check wood prop laminations. Questions on this? Also, this is a really, really good check to do if you fly a constant speed prop as part of your pre-flight. Now you wouldn't have all of these specific tolerances, but just know your aircraft and go up to it and do each of the wiggle wobbles. If you do it and also like, well, what? That's not normal. And that saves you from possibly blade departure in flight. Some things that we can do for constant speed propellers. We can still repair small nicks and damage, but it will be more limited than a fixed pitch prop like we had seen in Macaulay. They might say, oh, you can't do 6 inches near the hub, or they might say 8 inches, like you can only do it out here, or it's not as critical, so make sure you pay attention to those. Repair to shank area, not typically permitted. There may be a rare occasion, but not typically permitted. That's a good place for a break. Come back at 38.
I don't understand why. I'm looking at it and I'm looking at it.
Yeah.
It's right.
What did you put for FA?
At E cylinder. F case. I still got one wrong. I don't know why.
G would be cylinder. E cylinder, F case.
Yeah.
What did you put for G?
Piston.
And A is the articulated rod.
Yep. Articulated. D is master.
D is master. B is crankshaft.
That's right. B I put wrist pin.
Wrist pin's at the top, isn't it? Where it connects to the piston, the rod to the piston.
That's the only one I was questioning. Articulated rod was
I put crankshaft for
B.
B. I haven't submitted it yet. I still need to do the last 4 questions.
That's probably what got wrong. I don't know. I was trying to find a lead on that.
So did you only get the one wrong?
I got 2 partially wrong.
Oh.
The other one I got was 7. And yeah, I haven't found
I said two-piece master rod dynamic vibration.
Never wanted to go back.
Two-piece master rod dynamic vibration. I changed master rod, cause I had hub,
Just for the love of the game.
master rod is what I chose from the second attempt. So that may be right.
No, actually the very next line.
I'm not going on sides.
I was gonna go with hub, but I went to the master rod section instead of crankshaft section, and it looked like that was it, as well as the picture,
Just trying to get it up
which
picture.
I don't have the picture. And
Okay.
the picture had crank, or the master rod and pin kind of in the same line,
Same line.
so that's what I went with. And did you find a picture in the manual for question 9?
9, I did get that all right. I did not find, not a verbatim picture. But I went, the more I looked at it, the more I broke it down.
Yeah.
It made sense to me. The toughest ones are, I would say, is H and J. Cause
Yeah, J is some sort of gear.
that's, I believe, that was the cam gear. J was the cam gear. I did get this one right. H was the, you can barely see it, but it's the actual, where the rollers actually ride on. You see it back there? You see it, you can see one of the lobes.
Oh.
Just barely though. And then G is an actual roller. You can, it's pointing to an actual wheel on the roller. And then F is your tappet lifter, where the actual rod sits in. Tappet and tappet guide, yeah. Yeah, there, I don't know if there was a picture of the whole thing. Kinda had to look at several pictures. Of course, you do that sometimes to get money. Yeah, that's not the right picture of this. Hey, I got 100 this time. Okay, awesome. You were right about the crankshaft, and the other one was master rod. So,
Were the other 3 questions in the manual too? Or those like, I haven't really looked at them much. K's.
which one, 9, 10, 11? Or,
8, 10, and 11.
throws are found on the crankshaft. I found that, I searched that when I was insurance. I could not find, it may say in there somewhere. Number 10 was in the manual, or not, number 10 was in Jepson,
Mm.
and number 11 was also in Jepson, right next to it.
Okay.
My dog got hit by a propeller. Well, thank you. The plow. The plow. The plow.
Last flight, I was introduced to the dog that tries to get hit by a propeller.
Oh no.
Okay.
I'm sure you're familiar with him.
They run all over the airport.
I saw him in the fog towards the beginning of the year.
Oh yeah.
And he's the white dog in
Yes.
the fog, and I was out by the King Air. And I'm pretty sure Amanda thought I was crazy.
Oh no.
Go, no, do
a little damage. It seems like such a rough cut file. Wouldn't you want to use like a thinner file?
Yes. Like that little baby one I have.
Yeah. Like maybe those little baby file sets could file in like this thing. Oh, there you go.
Exactly.
Just little bits.
He's nice and yellow.
I have one of those file kits where it has the little baby file that has like a full size handle, so it's like grabbing all the Your wrist doesn't hurt, but
Right.
you can.
It's like taking big hits.
It's like, well, I'm trying to snap the file because I have like so much pressure
Right.
behind it.
Right.
I don't have like little.
Yeah.
Yeah, it's like if this was on the end of this.
Oh no.
I mean, it works.
Yeah.
That's a lot of screws.
Yeah, it is.
Glad we don't use these anymore. Normally.
Not
Normally. Mr. Williams, Mr. Dan Williams. Do you know him?
He's a. Wait.
Oh shoot, I forgot the name. Yeah, he's all the way down there
Yeah.
at the airport.
Yeah.
Yeah,
I feel like I've heard the name. I never met him.
yeah, he's the cursed name we're not really allowed to talk about.
Uh,
But he got his friend over in Venezuela. They hung a twin row. I think it's a 14 piston rotor radial from his garage ceiling with the propeller attached. They have attached to a motor to be a clock. And then they've also got I think not one of the most collectible ones, but like a cup hanging from the ceiling. Personal garage.
so wow. That is so cool.
That was great.
Wow. Alright, let's see. Oh, still missing some people, but the next slide has your next answers. So if they don't come back, they won't get the answers. Alright, so some more things with constant speed propeller. One big difference between some Macaulay and some Hartzell is that, so I talked about how to be greased for all the bearings and seals inside of the hub. Macaulay, when they manufacture or overhaul a crop, they fill their hub with the oil, the greasy oil that it needs. They put red dye into that oil, and then they seal it all up. So the ones, now not all Macaulays, but the Macaulays that do use a red dye, they do not require any servicing. It's in there, it's sealed up, it works from overhaul to overhaul. So, on a Macaulay that has the red dye, internally lubricated with red dyed oil, which is independent of engine lubricating oil, so it's all self-contained. If you see red prevent overpressure on the seals. So they will have, I'll have a picture of it, but they'll have two grease zerks. You're gonna obviously fit your grease gun onto the one. The other zerk you must remove so the grease can squish out. Any excess grease can squish out that zerk opening. Otherwise, you are going to destroy the inner workings of that prop by overpressurizing it with too much grease. And then some Hartzell propellers, a Hartzell compact, it actually has a nitrogen charge. So you can see that on our Aztec stands. Those had the Hartzell compact props that has a nitrogen charge in front of the hub of the prop. And so that would need serviced according to the manufacturer's instructions. And then we're gonna talk next week about something called a hydromatic prop. They're old ones, but they still ask you questions about them. Look for oil leaks. So your listening guide where it asks specifically what do you need to do to service a constant speed prop, grease it, or check a nitrogen charge. So you may need to grease a constant speed
big reactor. Like massive.
Alright, now we all got our gallons of milk.
Imagine that. Take the entire reactor. Small town.
Oh, no, grease the prop, check nitrogen, right?
You need to make a big reactor.
I didn't realize there was nitrogen.
They're blowing up the world. They're definitely because screw you. Neither did they.
jumping into next week. It's great. So the actual hub, Chad, can you grab that hub? And just hold it up so everybody can see. So the actual internal workings of the hub need grease for the blades to change within their little working mechanism. But then when you have a propeller governor that's sending oil through the center of the hub, that does use engine oil, but that is separate from the blade turning in the grooves with the seals.
But then the nitrogen is for the turning, it's not for lubrication.
Correct. Nitrogen helps to turn. So that is, I'm going to talk all about what props have nitrogen, how that works next week. Any other questions on that? So here is a picture. You have a noser here and a noser there, but not everywhere. A there. So they will tell you what one to remove, what one to pump grease into. Typically, hopefully, they'll tell you the one that's easiest access then you can remove that one. Used to be common that they would tell you to pump in grease until you see it coming out the opposite zerk. But then they discovered that tended to over-grease props, and they would have seals starting to fail because they're getting too chubby in there. So typically now they say no more than 2 ounces. So to measure out 2 ounces and just that much in. So be very cautious of not over servicing your prop. So where would you go? Where would you go to know how much grease to put into your propeller? Airframe manual, engine manual, propeller manual. Propeller manual. Now, could the airframe manual tell you how much grease to put in the prop? They can, but the King Air manual, it'll say service the prop with this much grease, because that aircraft with that PT6 is supposed to have a certain Hartzell propeller, and they know the Hartzell says to do this much grease. Now, could that change? It for sure could change. The propeller guys are going to update their information probably before the airframe guys catch up. So always go to the propeller manufacturer manual, because there's going to be times in the past when I was having people do labs and someone got a wrong answer. I'm like, but that's from the airframe manual. Oh, ha, ha, it is. Some Hartzell props now use a special grease that has anti-friction and plasticity characteristics. So that means it reduces friction most easily under pressure. And they have a new service letter that calls for NICO GN 3058 grease. So you don't have to know that. Just know that. Always check if there's updated information that you should be using. If you have your prop overhauled, then you'll lubricate it 1 to 2 hours after the first 1 to 2 hours after operation. And here's that really, really important information you must abide by when you grease a prop for the lab. Remove 1 zerk from each blade before greasing. And then the Macaulay's that has the red dyed oil, no lubrication required. There you can see what happens if you over-service your hub with grease and it blows its little guts out. Questions on that? So steel props, clean and inspect them. Magnetic particle, dye pen, magnifying glass, all repairs must be done by a repair station. Composite props, clean and inspect, all repairs must be done by a repair station. And I think that was a question in your listening guide. What can we do to steel props? Nothing.
Inspect.
Nothing at all. Anybody know what that aircraft that's at the top is? Boeing 377 Stratocruiser. The post-World War II commercial transport aircraft. They have hollow steel blades on those props. So hollow steel, 4-blade propeller. How much do you think one of those propellers with the hub weighs?
200.
Got 200, so if we take that big old thing off,
1,500 pounds.
got 600,
1,500.
1,500.
Always going in the right direction.
864 pounds. But then it had 4 propellers.
And they were hollow.
And they were hollow. There is massive though.
How much of that's the hub and how much is just the blade?
Ooh, that's a good that would be the hub. reminder of composite blade construction. We have this nice foam core, but we need lightning rod, composite on the outside. How would is a way you think you might need to test or inspect composite propeller blades. Exactly. Going to test. So that is something that you do need to do to composite propeller blades. And last but not least, our propeller governor. I kept talking about governors. Has nothing to do with politics. These are the good governors. They do not, actually they tell a prop what to do, but it's good. They don't tax anybody. Anyway, not salty. So this little governor dude will set somewhere in here, and there's a little control that goes to the cockpit, and then the oil circulates in here, circulates through here, up into the prop hub, and changes blade angle. We're going to talk next week all about the inner workings of this propeller governor, but this is what he looks like, and we can't do anything with these. We cannot take them apart. There's nothing to service on them. But you do need to check them because there's a lot of oil in there. Oil is what makes them work. So you make sure there are no oil leaks. And you check security of mounting. So what does that mean? So it's bolted onto here. That means you grab the little buddy and go, and it should not do that. It should be secure. Make sure your bolts are properly torqued. And then check controls. So you go to the cockpit, take the prop lever control, because the prop lever control is what connected to this little control arm that's stuck right now. There we go. Make sure you have freedom of movement with that, and nothing is binding up on there. So in your listening guide, when it says what to inspect on your governor, oil leaks, you can choose 2 to 3, I think ask for 2. Oil leaks, security of mounting, or check controls for proper travel. Wes Jones. Alright. There's a bunch of tropeware questions. I'm going to save those to sprinkle throughout next week. Like happy confetti. And we're going to hop a little bit into balancing, tracking, and blade angle. Any questions so far on what we talked about, or from the listening guide? There's a couple more that we'll answer on the listening guide. All right. Deep breath. You're doing well. I'm very impressed. Okay. Jefferson, chapter 12. If you come back to study this or prepare for testing or do labs, Jefferson chapter 12 will actually be a bit more helpful in some of this than your textbook. So if you're not finding helpful information in your textbook, Jefferson is helpful on balance, tracking, all that stuff. So we're going to talk about checking blade angles, tracking the blade, and balancing the blade. So, why do you think it's important that we make sure this prop is properly balanced, that the blades follow the same path and plane of rotation? Why do you think that is important?
Minimize vibration so it doesn't fall apart.
Minimize vibration. So all this is to minimize vibration so we don't go, yeah, bye-bye blade. Actually, yeah, like that. So, I'm going to show you a video of a somewhat scary story with a rather sad, unfortunate, disappointing ending of, makes you say, there's people like that out
Big insurance, big pharma, big utilities. As Attorney General, Mike Cox beat 'em all, saving Michigan seniors and taxpayers billions. Marine, homicide prosecutor, Attorney General. Mike Cox for governor.
Good morning, ladies and gentlemen. Welcome to Grumman Pilot's YouTube channel. And today we're going to talk about a dangerous propeller vibration that's in the propeller. It's not the motor mount. It's not the mount that we've talked about before. It's actually in the propeller being mismatched. We had one airplane that, because the paint job on the propeller blades were different, one airfoil had a different shape than others. This airplane shook and shook and shook. And after everything we had done, including motor mounts, dynamic balance, we sent the prop to Cincinnati. They discovered the problem, they fixed it, we got back a very smooth running airplane out of the deal. Now in this particular aircraft, the vibration was so bad that we saw this, what we thought was an oil leak underneath the belly, and then we realized it was the cracking of the outside skin along a bulkhead under the the cargo compartment. And we investigated that. We had to drill off the top of the cargo compartment to get in there, but we had to solve that problem on the bottom with 99 rivets with a DER and a patch, as well as putting it all back together with high sol contact. And then we had to make and replace all the trim tabs on both ailerons and on the rudder, which had vibrated off over the years. And so finally we'll show you a picture of all the rivets on the belly of the aircraft. It was not a fun job, and still the airplane shook because the propeller needed to go to the shop, and the owner decided he wasn't going to do that, and that airplane probably still shakes to this day. He doesn't bring it to us for annual anymore because we can't pass that airplane off. It shakes that badly, folks. So we hope you found all this useful and informative. Thanks for watching, and have a good day flying your Grumman.
So there are people. There you go. Freckles. You happy kitty.
Is that because all the Grummets are cats?
Oh, that makes sense. Yes. So just for you to realize that when you have a prop out of balance, it's going to vibrate, and it's affecting way more than just your comfort in the aircraft. It's affecting your engine, on its mounts, affecting everything in the aircraft, throwing off all your trim tabs. That's bad. That's some bad vibration. So, balancing is critical. I don't know if I should, yeah, I'll go ahead and tell you this. It's not super often that you will actually statically balance a prop. We're going to talk about static balance and dynamic balance. But you need to be aware of the procedures. You're going to go through the procedures in the lab because they will ask you about them on your orals and practicals. But we tend to send this to a prop shop, but it's something you could do. So static balance, what do you think that means? What's the word? Static.
Like on the workbench.
Exactly. You're going to take the prop off the airplane and set it on a special arbor and do it stationary. So static balance means the propeller's center of gravity coincides with its axis of rotation. So that means that the center of gravity of our prop should be the same, boom, right in the middle, where its axis of rotation is. So that's static balance. And dynamic balance, what do you think we have to do when we dynamically balance a prop? Yes, we're running that engine up to whatever RPM they specify, but we are making sure it's balanced while it's running. Somebody watching you. So, it means that the center of gravity of the blades rotate in the same plane of rotation. RPM, so that means that as this one comes around, this one's coming through the same exact plane of rotation, and this one's not like that. Coming around. And yeah, they're both in the same plane of vibration. And also that their weight in the blades is the same. So, but the biggest difference is a static balance, stationary, dynamic balance, dynamically moving. Both of them require special equipment. Dynamic balance performed with engine operating, special equipment including an accelerometer, which will be mounted on the engine to tell the equipment how fast that prop is rotating, and an analyzer that will be figuring out how much vibration we have, and then reflective tape is actually put at a precise location on the prop so the analyzer can see that reflective tape and know how much we're vibrating. Vibration for dynamic balance is going to be measured in inches per second. So this is something you should be familiar with. Inches per second, they won't say that. In the manuals, they'll say ips. So when you hear ips, it's not a version of oops, hopefully. It's IPS for ips, inches per second of vibration. And so Hannah next week or the following week is hopefully going to be able to do a dynamic demonstration of dynamic balance. And she'll set up a machine and show you what it's looking at. But you'll have a chart that comes with the machine, and it'll tell you, this will tell you how much vibration it has, and it'll tell you to put weights at certain locations. It clocks everything to try to bring that into balance. Now, it's very, very important that you read the manual carefully and understand the manual for where you place the weight. So typically, it'll tell you to attach washers to the screws or bolts or whatever that are on your spinner bulkhead. But if you place them at the wrong place, or put too many at the wrong place, or put them on the wrong side, what do you think could happen?
It's out of balance.
So first of all, it could be out of balance. What if you place them where it's at the clock position that this says on here, but you're supposed to put them, here's the thing. So this says if you put it at 6 o'clock, you're going to bring it into, if you put 2 weights at 6 o'clock, you're going to bring it into balance. But so this would be the dynamic balancer machine. But your prop manual says you are not allowed to put anything in this location. What might you be able to do?
Put an 8 on either side of it, and that should be equivalent to the 8 in the middle.
Exactly. So you might have to split the weights. So you put, instead of 2 weights here, you put 1 weight here, 1 weight here to even it out, and it should even itself out. So you take this information, but then you go to the prop manual, make sure where you're positioning those washers is the correct position. Otherwise, you could get a cracked, I'll pass this around, but there's a crack right around this hole because they placed too much weight on the wrong side. This situation, pass it around. The manual was actually kind of confusing because it said one thing and then later further down it said, in this situation, which they happen to have, do this instead, and they didn't realize that until deviation is less than 0.07. So that's generally what they're looking for. And do you think, let's say you have a slight imbalance, is it going to be worse at a higher RPM or lower RPM? We got a higher, we got lower. Let's take a vote. How many say higher? How many say lower? How many say I want to be out in the sunshine right now? Me too. So, actually, the effective imbalance is going to be greater at higher RPM because you're spinning faster. So your forces are going to be higher and stronger. All of the forces are going to be higher and strong. All of the
Which
forces.
forces specifically?
All of them are going to
Like,
be
is
higher.
there any that like really call
And
out to you?
so, moving on.
There are things that are 7 years out of the room.
You're going to vibrate more at higher RPM. Any questions on that?
Difficult portion.
All right, so I have a video to show what it might look like to do a dynamic bounce. Look at that.
I'm Mike Rhodes with Air Tractor. Today we're going to walk through the steps of how to dynamically balance a propeller. It's important to have a balanced propeller because an unbalanced propeller has a detrimental effect on airframe components, electrical connections, and cockpit equipment. So let's get started. A variety of dynamic balance equipment is available. Here at the Air Tractor factory, we use the Honeywell Vibrex 2000 Plus system. That system contains everything you need for the balance job. Okay, so the first step is installing the propeller balance equipment. That consists of an accelerometer mounted vertically and a laser detector that will measure the RPMs of the propeller and the clock position of the propeller. On the PT6, the most convenient place for mounting this equipment is the forward upper propeller overspeed governor stud. And so we're going to pick up that existing stud with this bracket. So I'm picking up the upper forward stud on the overspeed governor with the accelerometer and the laser eye. As we tighten this up, it's important that the accelerometer be oriented parallel with the propeller disc. Since we're a tailwheel airplane, that's not necessarily parallel with vertical, but it is parallel with the propeller disc, so that we're measuring vibration in the up and down direction as the engine turns. Okay, the next thing we're going to do is run the cable harness, and it's important that we keep the harness from making contact with the hot exhaust stack. So I'll secure that harness with zip ties. The next step is to define 12 o'clock for propeller orientation. The next step is to install the reflective tape. The reflective tape is installed so that with any further rotation past 12 o'clock, the laser beam falls off of the reflective tape. There's a little blinking red light that indicates when the laser sees the reflective tape. Now that the cabling is secure, we're going to move the airplane to a place where we can do safe engine ground runs. For our propeller balance ground runs, we're going to park the airplane facing into the wind. We want to be away from any trees or buildings because we don't want any turbulence associated with those things. And we're going to check and make sure that we don't have gravel or sand on the ramp underneath the propeller, because we don't need any propeller erosion problems. After the first balance run, we've measured an imbalance of 0.37 IPS at a clock position of 12:16. So we're going to build up a set of balance weights now to correct for that imbalance. So our system has calculated that we need 26.2 grams, and we need to install that at 6:16 for a clock position. We have optional weight locations on the spinner backplate every hour on the half hour. So we'll install our balance weights at 6:30, and we'll let the box know that that's where we've installed the weight. Okay, we just completed our second run for balance verification, and I've got a 0.03 IPS imbalance, which meets the criteria for a very good smooth propeller. Thanks for watching our propeller dynamic balance tutorial. For more information, contact your air tractor dealer or log on to www.
Thank you, sir. Any questions?
.airtractor.
On that. So now, what?
Say what you want, but it's balanced.
It is. I'm impressed. Hannah would go into more detail with you on dynamic balancing later. But now we'll talk about static balancing because I'll start the groups Monday to be cycling through statically balancing a prop. You'll be doing this as groups. What are some things or reasons why we might need to check the static balance of a prop? If you paint it. So if you paint it, unless you know that you are an expert, perfectly coordinated painter, you got exactly even paint on both sides, you should probably statically balance it to make sure it is in balance. What are some other things that might have happened to it that you would need to balance it? Check the balance. If you filed aggressively, you're like, uh-oh, I should check it. Reese, did you have one, or is that
No, that was the same one.
still? So, anytime, basically, that you remove or add any kind of weight, so any kind of painting, maintenance, repairs, it's a good idea to check the balance. So there are special arbors that you use to balance your prop, and there's all sorts of different styles. But you would insert this through the hub. It should be perfectly round. And then that would either go into something that can freely rotate or balance across balance knives like that, where it can freely roll. And there are two ways that you need to balance. You're going to check vertical balance by placing the prop vertically. And then you're going to check horizontal balance by placing the prop horizontally. So you're checking both of those. And those are two separate checks. So when you do it vertically, place the prop in vertical position. If the blades start to drift horizontally, that means it is vertically unbalanced. So that can be a little confusing. Vertical, if it drifts horizontal, that's bad. That means it's vertically unbalanced. of the hub. So if I'm drifting this way, which side of the hub am I going to add weight? Side A or side B?
Put your hands on.
Correct. So it'll be side B because this side of the hub is heavier. It's drifting it down, so I need to add weight here to pull it back this way. So for vertical imbalance, correct it by adding weight to the light side of the hub, 90 degrees from the propeller's horizontal center line, which means vertical, we're drifting this way, so it would be horizontal center line. This is 90 degrees on the light side of the hub. Any questions on that? Yes.
Would there be any scenario where you've added that weight on your side B, and then the next time you did it, the other side's too light, that
Sure.
cause you to, in that case, would you then take away some of the weight you put on?
Sure. Yep. If
So
that.
it's not only, or should I say it's not always just adding?
If you had that
If you had
option. Now, very rarely would that actually happen, that you had already added weight. Let's say if we drift here, we add weight here. 3 years later, we're drifting that way. Oh, I have it in the exact opposite, so I can take it off of here. Not too often it'll be that nice to you. Could it happen? For sure. But
What you're saying is don't structurally remove.
correct. Correct. If you had weight that you had added, for sure, you can take those back off. But you're not going to file down the hub. Then, so first of all, you're going to vertically balance it, get that hub balanced, and then you're going to check the horizontal balance, place it in the arbor, and you put the blade horizontally. Yeehaw! And now, whatever direction it starts to drift, if this one's pulling it down, this is my heavy blade, then what do you think you could do on an aluminum prop? If this blade is getting heavy. Yes. Look along this edge. I bet there's nicks that you followed out. Just follow on out and it can become balanced again. Now some props will have options, other options to statically balance horizontally other than removing material, but which you're going to see in your lab. But that is the most common to remove material from the heavy blade tip. What did I say when I was over there? Did I do it backwards?
No, you did it right.
Okay. So yeah, if this one's drifting down, I'm going to remove material from my heavy blade. One of those things when I lay down at night is like, wait, did I say that right? No, I got it on there wrong. For a wooden prop, look at this. You can add solder to the blade that is light on the tipping. So just inspect it, see, oh, is there any solder missing? If not, find the best spot. You can add solder to the light blade. So aluminum prop typically remove material from the heavy blade. There may be other options, but typically remove material from the heavy blade. And I think that's a listening guide question. Aluminum versus wood. And also for vertical unbalance, add weight to light side of the hub. Get all those listening guide questions. Yeah.
Can you help me understand
long as you have it perfectly vertical. Because this is all being pulled down by gravitational force. And vertically, you could do it this way and then do it that way just to double check and make sure.
A lot of it be because they're symmetrical, like the top there is the same weight and size as the bottom on the opposite side.
It should be.
So it's not just like that it's gravity pulling down, it's pulling down equally on both sides.
I think so, if I'm tracking. Also, so let's say you balanced vertically, got your hub balanced, then you balanced horizontally, got that balanced. After those two things are balanced, then you're going to pick like 3 different positions just to double check yourself. So if the hub is balanced and the blades are balanced, it should, no matter what position you put it in, hold itself there. So you put it up there, put it down there, maybe another one in between. So it should be perfectly balanced in every position and just hold itself no matter where you put it. So what do you think should be the conditions of the environment in which you are balancing? No wind. So make sure you do this inside, doors closed, no fans, still air. If you have a 3-blade prop, you're going to pull down each blade into the 6 o'clock position, and it should not move. And you have to do that to each and every blade, because you can't do just a vertical and then a horizontal. So you just check every single blade. And manufacturer's manual will tell you when to do hub versus blades. Not too often you would statically balance that. If you're having vibration issues, you probably send it to a prop shop, because this would be a constant speed prop and have lots of other stuff going on. Any questions on that? I have a little video of statically balancing. That's not an air tracker, so sorry.
Hi everybody, I started balancing my propeller and then realized maybe a video would be good for other people to understand. Here I've mounted the propeller on a very sharp metal edges that are leveled with a dowel, and you can see that left blade was very heavy. Now I rotated the propeller around, so now it's going to be the right blade that's heavy. So we're going to retest it again in this direction, make sure it's just not a test setup here. Nope, that right blade is definitely heavy. So what we're going to do is spray black paint on the back of the left blade, and we're going to get the light blade to become heavier by using black spray paint. I'm using flat black because I like the back of the propeller to be black. Just one more test here just to make sure. Oh, look at that. That right blade's just heavy as anything. So here we are after we sprayed some paint on and let it dry. Yeah, you must let the paint dry because it weighs more when it's wet. And you can see it's much better now. It's not slamming down and hitting the table, but it's still hanging a little bit low. And if we try to reset the balance, let's see if it goes back to the way it was. Okay, let go of it. And it's slowly drifting back to that right blade being low. So let's go spray some more paint on it. Or let's try it one more time here, just to make sure. We don't want to go spraying paint if we don't have to. Yeah, that right blade's still a little bit heavy, so let's just touch a little bit of paint on the left side. Let's upset the balance cart here a little bit. You can see it's just oscillating back and forth. You want to do this in a no wind situation. I got the hangar door shut. There's no wind blowing in here. And it's staying level. This propeller's ready to bolt back on the airplane. Thanks for watching.
Oh, no, thank you. Any questions on balancing?
Recap the big difference by adding solder to the tipping tool.
So each of these, whether they're screws or rivets, now you would have to go to the manual to know what kind of solder on the heads. And also, this one doesn't have it, but some will have more obvious seams that are soldered over. Just to keep, and then you file it, sand it down to make it smooth, so you have smooth airflow. So you pick one of those and just add a little solder, and then you would smooth it out, but you are allowed to do that. And sometimes that solder can chip off, so you might have to add it anyway, which you are allowed to do. So you would check and see if there's a good place to add solder that needs a little tiny repair. Any other questions? So the next thing is blade tracking. So I mentioned it a little bit, but it checks that position of the propeller blade tips are moving in the same position relative to each other. Here you go. So metal propellers up to 6 feet in diameter must be within 1/16 inch of each other. So you would chalk this plane, make sure it cannot move. What else would you do before you come up here and start rotating the prop? Excellent. Disconnect your leads so you're safe. And then you would put something at the bottom of the blade. You could put a little box or whatever, tape some paper to it, make sure that doesn't move, and you put it up as close as you can to the tip of the blade so you can mark where the center of that blade travels, and then you mark where the center of the next blade travels, and those marks should be within 1/16 inch of each other for a metal propeller. And a wooden propeller is allowed 1/8 inch. So why would a woodchuck? Anyway, why would a wooden propeller be allowed greater tolerance? Yeah, it's gonna flex and move more than metal propeller does naturally, so that allows for that. So here's showing you, tuck the pencil up against the prop, make the mark, a bench or box or whatever, doesn't matter. This is from prop manual, just shows you wood block, and bring that blade right up to it. Matthew.
So that's for 16 inches for metal props up to 6 foot. What about bigger?
You had to go to manual, because even with these, it might be a specific manufacturer could make a tighter tolerance. Bigger than that, definitely go to manufacturer. That's kind of a generalization that should be tested on. You say, well, it's this unless the manufacturer specifies otherwise. And that's a listening guide question. Anybody not get that? Alright, I'm going to subject you to my dark sense of humor. sure they're actually torque right, holding that in. What other things? Yeah.
Your aircraft's like level. That matters.
Yes, double check that you have everything set up correctly. Yeah. Did somebody put shims in there? Excellent, because some props you are allowed to shim it, so you want to check that somebody put some in there wrong, or you may be allowed to put some in there to correct the out of track. One other thing. Yes. Exactly. So check for dirt and debris, check for crankshaft alignment. All right. Are you ready? So I mentioned when you are in the prop arc, you're checking track or anything else in the arc to do maintenance. You must make sure your spark plug leads are off. This is Bob.
Oh my gosh.
Bob has no arms. Knock, knock. Who's there? It isn't Bob.
He could just kick the door. Steel toe
It's pretty
boots.
dark.
No.
I'm sorry.
That's Swiss cheese.
Yes. So, how many of you have heard the story of this poor guy?
We discovered it yesterday.
Oh, that's great.
Wait, what?
Who's we?
Some of us are discovering it now.
Okay, so
Start from the
thank
beginning.
you,
Start
because
from the
I wanted to tell a story. So there was a myth out there that it was a, I don't know, angry, jealous wife that took a chainsaw to the airplane. Not true. Not true. What actually happened is even better. I don't know. I get jollies out of it.
You get jollies out of the other story too?
Not as many jollies.
So it was a surgeon. No, so there are really.
Stupid stories.
Yeah, he was.
Oh, no. So there are actual, legitimate, amazing surgeons like Shane's dad. But then I happen to work with surgeons that, anyway, ask me a couple boys. Anyway, a surgeon is starting up his Dr. Killer, his aircraft. And the battery was dead. So what does he do? He hand props it. Was it tied? Nope. Was it chocked? Nope. Did he have the throttle mixture set correctly? No. So his Saratoga takes off. Wah! He gets thrown off. It says he tried to hang on to it until he couldn't anymore. Saratoga took off, destroyed, sliced through 4 Piper Warriors before it came up this horse Seminole, and finally stopped.
Oh, thank goodness.
Destroyed 4 aircraft that were owned by a flight school. They had to go rent stuff from somewhere else. Really, really bad. They tried to bring a lawsuit or something against him, but then, but then it's like, oh, well, actually, maybe the brakes were bad in the aircraft. It's not his fault.
So it was a mechanic's fault.
Yeah.
Mechanic's fault.
But what's a really cool, though sad, thing that you can see about this?
The effective.
Yeah!
thing.
The geometric, actually the effective pitch. Oh no! This is solid material. They're showing the geometric pitch. That's so sad.
I like the Jello better.
So sad.
So that was fun.
Yeah, very,
Supposedly.
very unfortunate. All right. All right. How are you all doing? Here's some options. So we can talk yet about measuring blade angle with a propeller protractor, which we're going to talk about how to learn how to read a protractor. And then you would do it on Monday, or, and it's not super long, like we would have time to do that yet today, or we can just stop lecture there and I'll give you a lubrication lap to do. So option A is grind through the rest of lecture, but then we'll have just more review time and lab time Monday. Or option B, just stop lecture and give you a lab to do right now. So how many say A, grind on through lecture? How many say B, I can't take it anymore, let's give me a lab? Okay, there's more for B. I'm kind of done too. That's a lot of talking. I think I've talked more this week than I have my entire life. Actually, every class. Well, yeah. Okay, so.
Third option?
Go home.
So, stand by.
Stand by.
I'll open up the lab. put the Zerks back in, make sure your neighbors are paying attention, everybody paying attention. Thank you, thank you, thank you. So when you put the Zerks back in, just snug. Do not torque them. Do not tighten them. Just snug. What do you think would happen if you stripped out a Zerk fitting? That has to go back to either manufacturer or certified repair station. Such a simple thing, but such a bad day. Here's a note you might want to write down. Bless you. You could find, but this will help you. So Hartzell serial number is 2 letters followed by a number. So when you're looking for the serial number on that prop, look for 2 letters followed by a number. Questions on that? Alright, so that was 4. Like I said, don't worry about the lap supplement. Lap 5, prop blade repair. Pretty straightforward. There's links again. There we go. Yay! Okay, so the links are working. And then part 2 of this lab, propeller blade repair part 2. Make sure you thoroughly read through all this information. After you thoroughly read through all this information, you will get a propeller blade from me, and I get to have some anger management. Then, after you receive the nick, you will show me your nick removed. So only filing out the nick itself, not doing a 10-to-1 yet. You're going to sign off for the nick removed. I'm going to look at it, make sure you got down the base of that. And then you'll blend it out 10-to-1 and get sign off for that. And then you're going to paint it flat black and get a sign off for that. So when you receive a prop, just note to yourself, it must have 3 sign-offs. If you just laze through everything and paint it up, you come to me or Hannah, say, give me a prop finished, and we look at our sheet and are like, we did a sign off, removing the nick or blending it out. Guess what? You get another one. Are there any questions? Okay, yes.
What do you expect we should be changing stuff with?
Very good question. So I don't have it up, but starting Monday, I have a schedule stepped out like I had for turbine class. So Monday there's going to be groups to begin static balancing, but from Monday on out, I'm going to have scheduled group labs. So anytime you're not in a scheduled group lab is going to be time to do the individual things. So this sometime throughout the rest of the class. So what I would recommend is get the first 3 labs and the listening guides finished. If you get it today, that's great, but you have time Monday also. Those will be priority. So I don't expect to be giving anybody a blade today. Or I don't even expect anybody to start actually lubricating today. I want to release the lab so you can start working through the information. And then blade repair, lubrication, some others that'll open up. Those you can kind of intertwine whenever you're not in a group lab. Take time to do it individually. So, in the class Wednesday the